Okay, we're going to solve a couple of exponential equations that are a little more complicated. One of them is a little more complicated than the previous video. So in the previous video, we actually solved a problem that looked similar to this. It was a little bit different, but it looked similar to this. And we solved it by taking the log of both sides. Now you can use any log that you want to use, log to any base. But an interesting thing is going to happen when I use log to base 10 on this one. So normally you try to get the bases the same. You see if you can get the bases the same. But 10 is not a power of 5, so we can't do that here. So we're going to solve this by taking the log of both sides. That's how you get the exponent out of, or the x out of the exponent place. But when I take the log to both sides here, I'm just writing plain log, which is log to base 10. And so an interesting thing is going to happen on this problem. First of all, I need to use my third log property to get my exponents out of that position. So the exponent can move out in front. X times log 5 equals x plus 3 times the log of 10. I have to put that x plus 3 in parentheses. Now this is what's interesting. This is log to base 10 of 10. Well, that's just 1. So the log actually goes away over there. And I have this very simple expression now. And it's just a simple linear equation because log 5 is just a number. And so all I have to do are get my x's together on one side and my numbers on the other. So I'm just going to subtract x from both sides. And then I have x log 5 minus x equals 3. And then I can factor my x out. So I have log 5 minus 1 times my x equals 3. And I can divide by my log 5 minus 1. And so my answer then is this 3 over log 5 minus 1. And remember that in exponential equations, you don't have to worry about the domain. So this is my answer. This is an exact answer. If you want a rounded decimal answer, you can put that in your calculator and use your plain log t. All right, but here's another equation of a slightly different form. And so we've got e to the 2x and then minus 3e to the x equals 10. Now, this is a little more complicated because we have two terms with exponents, but we also have this other term that doesn't have the exponent at all. What you have to do in this problem is recognize that, first of all, these are different, but they're similar. And this one in particular can be written several different ways. The most useful way in this situation is to understand that e to the 2x can be written as e to the x squared. You see, you just multiply exponents. So this is not too helpful, but this is very helpful because now if I write it this way, then I've got e to the x squared minus 3e to the x equals 10. We've seen patterns like this before. It's a quadratic pattern. It's not a quadratic equation. It's an exponential equation, but it has a quadratic pattern. And so what we can do is what you do with quadratic pattern equations, you can use an A substitution. I call it an A. You can use substitution, whatever. But you need another variable. So we're going to let A equal e to the x. All right, so everywhere I have e to the x, I'm going to put a. Well, that means that this is going to be a squared, and this is going to be minus 3a equals 10. You see, now I can see the quadratic. Bring the 10 over, a squared minus 3a minus 10 equals 0. It's easy to factor. A minus 5, a plus 2 equals 0. Multiplicative property of 0 says this is true when a minus 5 equals 0 or a plus 2 equals 0. So this is true when a is 5 or negative 2. Well, a is not my original variable, x is. And it turns out that a equals e to the x. So I'm going to replace a with e to the x here. E to the x equals 5, and e to the x equals negative 2. All right, well, we can easily turn this into an exponential equation, remember that, let's use a different color here. Remember that the definition of a log to base b of a equals y, can be written in exponent form, the base to the exponent, because a log is an exponent. So b to the y equals a. I can write a log as an exponential statement. All right, well, I can also write an exponential statement as a log. So that's what we're going to do. We're going to go backwards. So e is my base. Well, log to base e is really the natural log. So the natural log of, now what's on the other side of the exponent is a, the argument of my log. So 5 is the argument of my log. And then that equals my exponent. Y is my exponent. Well, here x is my exponent. So x equals natural log of 5. Easy. All right. Now, this is an exponential equation. There are no domain issues. That's an answer for x. If we do the same thing over here, now the other way you could do this is you can take the log of both sides. Okay. So we have the natural log of e to the x equals the natural log of -2. Well, now here we see that we have a problem, because you cannot take the natural log or any log of a negative number. So this is not going to give me an answer for x. So the only answer I have is the natural log of 5.